Okay, so the exam, it's got, there's some questions that are really quick and easy to answer in this review. For example, let me give you one. Like, look at this. Arrange in order of increasing boiling point. So that means that there's going to be more than 10 problems on this exam, because there's some questions that are you just answer really easy. So this can't be worth 10 points. If you screwed it up, you lose 10 points. That's a lot for one simple little question. So there's going to be multiple questions like this, and that'll add up to be like 10. Then the rest will all be problems. Okay. So what are the big areas? The big areas are pretty much right here. I mean, you're going to have some problems that involve solutions, for sure. And what type? Well, just look at the quizzes or the homework. I think the hardest one would be something like, what I think is the hardest one. Those how would you prepare ones. You remember those? See, there's this kind of solution problem. How many grams are in something? But like here's a how would you prepare one kind of. How much water should be added? So, and then I've got another sheet of problems that we can also mess with. And then we've got these. What helps, I think, for these solution problems, right? How does the vapor pressure change? How does the boiling point change? How does the freezing point change? Just remember boiling point, elevation, freezing point, depression, right? Because then you know what to do with your delta T. Because you go and you calculate this delta T with a B, and you know that, oh, okay, I have to add this to the boiling point, right? Or what's the new freezing point? Well, I got to subtract that delta T. So the name, that's how I handle those. I remember the name of that stuff. Boiling point, elevation, freezing point, depression. And then they got into, I don't know if you remember this, with these osmotic pressure problems. To me, the hardest problem there was, does anyone remember? Finding the what of this solute? Finding the molecular weight. I thought those were the hardest because there were multiple steps, right? And remember that whenever you're finding molecular weight, using any of these equations to find molecular weight, we always started out this way. Molecular weight is the number of grams over the number of moles. That's how we did it every single time. And they always gave you this one. That's pretty much why we started out this way every single time, because they always gave you half of it. You just had to figure out the number of moles. And then you use one of these equations to get it. All right? Okay. So to get it, you got to remember what each of these variables are. Do you remember what the little i's are doing in there? What are the little i's doing in there? The number of ions. Number of ions. So if your solute is barium sulfate, right? You add barium sulfate to water, the boiling point's going to go up. The freezing point's going to go down, right? What set of equations should you use? The top row or the bottom row? The bottom row, with little I being number of ions. So the number of ions here in this formula is 2. So little I would be 2. Okay. And then we got into these kinetics equations. And I don't think this is that bad. It's just the algebra. Because they're going to tell you first order, second order, zeroth order. So you easily pick out the equation. It's the algebra that can get you. So you want to make sure you practice that. But if you remember, before we hit this, we hit problems where they gave you a bunch of experimental data. And you had to figure out what the rate law was. So you had to compare two experiments where the concentration didn't change and figure out the order. So those are all the problems that we can work through in general. And you're given this equation sheet, so this would be a good thing to hold on to and to use when you're studying for this. So want to just start at the beginning and go on down, or does someone have a particular question they'd like to work on? Yeah.
I did some of the questions yesterday.
Yeah.
And on 12.52, the only way to get 23 is if you divide 1.5 grams by the 6.5%, and then you multiply by 100. But what formula is that?
Okay, let's jump. Let's use this one. Let's start here. 6.52. What mass of solution containing by mass contains 1.5 grams sodium sulfate? So that.
Because I got the answer and everything. I don't know if I.
Yeah, we'll just work it through. We'll work it through. So what I want to do is I want to copy that mass percent. This one, right?
Yeah.
So I don't have to redo it all. There it is. That's the equation. And they say they're after mass of solute, right? What mass of solution? So we want to solve for this one. So that means we should have numbers for everything else. Okay? So mass percent of solute. What number do I put in for that? Jose, what number do I put in for this? This one. 1.5?
Oh, the percentage?
Yeah, this mass percent of solute. You'd put in, needs to be a percent. 6.5. Right? And the 1.5 is going to go everybody on top. Right? Don't forget the times 100. And then, I don't know, you can find X or whatever down there. And then, now this is where I have my way, maybe you have your way. My way is just recognize what's on top and what's on bottom. And then I can do it all in one step on the calculator. So I can visualize, I visualize moving the X up here and moving the 6.5 where the X was. Then I just do it all on the calculator. I would take 1.5 divided by 6.5 times 100. I have my answer. And the X is mass of solution, so it's going to be grams of solution with the units I would put on it. So 1.5 divided by 6.5 times 100, about 23. Alyssa, was there a particular type of problem in here that you thought was harder than the others? Or would you rather just start at the beginning?
I kind of want to start here, but I always have trouble with like the delta T, delta.
This,
All that stuff I have trouble with.
these guys?
Yeah.
Let's jump down to one of those. Well, that's okay. I don't want to start where you're confused. That's Mia. You have the handout of all these questions, and you see the question that she's looking for? What would be one? What would be one of them? I'm seeing if you can recognize the problem. She wants to do a problem. And she says, "Oh, one of those delta T ones." What would be one of them? Where? Yeah, what's the number of it, you're saying? see what you're talking about.
What is the molecular mass? Oh, it doesn't have a number. Yeah,
It doesn't have a number? I thought I had a number on everything.
Just keep going a little bit. Right there. Take it from.
Oh, I got to put a number on that. Weird. All right. Yeah, strange. Okay. Oh, yeah. It says freezing point depression. So this is definitely going to be a B1. A delta T type of problem. Okay. Okay. A 0.0182 gram sample was dissolved in 2.135 grams of benzene. The molality was determined by freezing point depression. What is the molecular mass of the unknown substance? You're supposed to get 123 out of this mess. Okay, so where would you start? Bowdy, where would you start? Oh, I have a no name on this one. Bowdy, where would you start? Anybody have an idea? That's where I would start. I don't know if it helps you because it doesn't, but it gives you a starting point, and it gives you what to look for. So I like to start with what they're asking for. So Bawadi, does that help you?
Yeah.
Because then what would you do?
Well, I think I knew that. I just didn't know what to do after that.
That's okay. Well, yeah, but what would you do now, though?
Well, we have the grams.
You have the grams, so that's going to be what? 2.135 grams? Does everybody agree? Yeah, the unknown. So this is supposed to be the molecular weight of the unknown. So that's grams over moles, yeah. But it has to be grams of the unknown divided by moles of the unknown, right? So it has to be the other one, the 0.0182. So I think it helps remove frustration, and it helps to make things go smoother and faster. Just keep following the logic. Okay. Now what? Kenneth, what would you do now? Molality formula. Ooh, that would be nice. Cm is what? Moles of solute over kilograms of solvent. All right. Now, this is kind of hard. If you've worked these problems before, this makes sense to jump to, because this is where your answer is. Here's your moles of solute. But I guess this is it. What the heck happened there? This is it. That is you're going to put right there. Now, how do you know to jump here, though? For me, I might have jumped right to this guy. But if you worked problems before, it's a little more insightful to jump to molality. It makes the CM equation make sense. That means you got to know kilograms of solvent in CM. Do we know one of those? Cameron, do you know one of those? Which one do we know? We know kg. It's just in the wrong units.
Yeah, it's grams.
The 2.135 grams of benzene. So And what sometimes might help you is instead of writing exactly what the equation sheet says, write down, change it a little bit for the problem. The solute's the unknown. The solvent is benzene. And then it might be easier to see. So this, we know, is right here. 2.135 grams. If I want to make that kilograms, move the decimal place how many times?
2.
How many?
2.
3. And make it smaller, right? One, two, three. 0.002. And now it's kilograms. So now all I got to get is CM. Right? So Kendall, now what?
We have CM, don't we?
Uh-uh.
What's the point
Did they
of
tell us
698?
CM? Oh, they did tell us CM, didn't they? Is that what CM is? How do you know that's CM? Because it has a little m on it. Wow. So I get my little mode of writing delta TF equals KFCM. That wouldn't have really done much, would it? We know CM. What was the hint that this was molality? That the little m, right? There's the hint. That's a unit for molality. So we'll solve for moles. Essentially just 0.0698 times the 0.002135 kilograms. Put that in down there. Hopefully we'll get 123. Complain, complain, complain. Yeah, so I got around 122. That's a good question. Andrea, did you get it to work? So do you see what the typical freezing point depression problem would have been? You would have had to have fine. Here's the equation for it. So there's so many variations of this. Usually they have you calculate CM. So you have to use the KF. That's why I have it up there. And they have to tell you what the freezing point changed by. Right? If it was 0, went down to 2 degrees below 0 or something, delta T would be 2. And then you solve for CM. But here they gave it to you. So we didn't need this. if we had them in homework and quizzes and stuff. It's still grams per mole. Don't even worry about it. Yes, and Drummond.
Can we do R15?
R15? All right.
It's like osmotic pressure.
R15. Whoop, wrong way. Let's try R15. Okay. It's another molecular weight problem. And it's osmotic pressure. So Jose, which equation, so you see R15 question? Okay. Which equation should I copy and paste and drag down there? Or R15. Which equation should I drag down there? Which symbol was osmotic pressure? Do you remember? Pi. So you've got two choices. It needs to be one of these two. Top one or the bottom one? Top one. All right? If it's going to be the bottom one, they better tell you what the heck this ionic compound is so you can count up the number of ions. They just said the funky word polymer, if you remember what that is. It's a huge molecule. Okay. So Andrea, they're after molecular weight again. Hey, do we just solve for big M and we're done? What's big M? Molarity. Yeah, so it's going to kill you if you don't recognize what all these units are, right? Okay. Big M's molarity, so they're not going to solve for big M. But we're going to use that big M to get what? To get the moles so we can calculate molecular weight. Right, so we're going to use that big M to get it. We're going to set up the big M equation. Whoop. Yeah, moles over liters, right? Because our molecular weight is grams over moles. So we have the mole. We're going to use that to plug it in. Right? So Kendall, did they give us the grams part?
Okay, we for sure have milliliters, so we have to turn that into liters. 25.9.
Oh yeah, we can do that. Move the decimal place over 3 places. That's going to be what? 0.0259 liters.
And then for the grams, we have the 0.031.
Oh yeah, we can put that up here. You see anything else?
Temperature.
Ooh. There's a good question, Kenneth. She said the temperature. That's going to be that T, right? Now, shoot, do we plug in 25 degrees Celsius? It needs to be in what units? And how do you know it has to be in Kelvin? Because of R. Exactly, because of R. So R is, oh no, we're going to use, what units are we going to use for R? What? The one with ATMs in it, Right. So remember that if you 0.0821, and you don't have to memorize this, just look at the cheat sheet for it. There's our big R. So you're right, T has to be in Kelvin. You add 273 to that, you've got 298 Kelvin. And my osmotic pressure, oh, please be in atmospheres. Oh, it's not, right? So you're going to have to convert those millimeters of mercury into atmospheres and put that in for your pi. And it has to be in atmospheres because look at that's what the R is in. You don't have any choice.
We also have
So Cameron, how do I get millimeters of mercury into atmospheres? Yeah, there's 760 millimeters of mercury. Again, if you're not sure, you just look at the cheat sheet. What atmosphere equals 760 millimeters of mercury? And he said divide, otherwise the millimeters won't cancel. About 2.08 times 10 to the negative 3. So that's what has to go over here for your osmotic pressure. So we'll solve for big M, and then Kendall's got it pretty much set up for you, right? Whatever big M is, then you can find moles by multiplying it by the liters. Put that last step into your molecular weight. And we don't have an answer for this one.
What'd you get? What's your final answer? Oh, okay, you got a big number two? You got a big number two? I got 8.5. Yeah, 20, yeah, 0.9.
So I got about 8.49 to 10 to the negative 5 for my big M when I solve for it.
I had a bad day.
So Megan, have you ever added anything up on the periodic table and come up around 14,085 grams per mole? No. So is this, we're supposed to look at our answers and say if they're ridiculous or not. It's ridiculous except for that one word up there. Polymeric. Remember that's supposed to be the big hint that, oh, it's this huge thing and you're going to get a huge answer. Yeah, it's just rounding. Somewhere around 14,000.
Empty spaces, and I feel like I want to answer
Yeah. So Kenneth, what type of problem wreaked headaches for you?
Like, what about like R12?
R12. Well, that's a good one. R12. Okay. Andrea, do you see R12? Okay. What equation should I copy and paste down here to work on R12? R12. They have a mess of problems. There's really only one hint that you have. Molality equation. So that means the molality one. That's the only choice you really have. Whoop. R12. Okay. So we need to pick R12. So we need to pick the molality equation because, right, they pretty much that little m. But then, Mia, where do you go from there? They want to know how much water should be added to 75 grams of fructose. Where's your answer? I mean, where is the answer at? Is it in the equation even? Is it even in the equation? It's kilograms of solvent. That's the answer. So when you give an answer, this is a hard question because they didn't say how many kilograms of water should be added. They just said how much water. So you're going to solve for kilograms of solvent because water is the solvent. There's your solvent right there. Here's your solute. So if we would have rewrote it, it might have helped. Moles of C6H12O6 all over kilograms of water. That might have helped. And then you might have recognized, oh, I'm just going to solve for this. And then I'm done. It makes it a tough question. So it's just like all the problems. In these concentration problems, there's always 3 variables. They always give you 2, and you always have to solve for the third one. What'd you get for the molar mass of that thing? Of C6H12O6. 0.15. Did anybody else get 180.15 as the molar mass? Okay, good. Good deal. So then you divide the two, you get your moles, put it in. You know what little m is? That's 5.5. Oh yeah, thank you, 0.416. About 0.076. So for you to get the most benefit, I think, out of this Sunday 7 p.m. pizza help session, I would try to work through these so you know which ones you're having problems with.
That was a VHS.
If it was morning. I don't want to eat hard donuts at 7 p.m. on a Sunday. Really? Would you rather have donuts at 7 p.m. instead of...